I'd like to welcome everybody. My name is Larry Arthur with the Indiana chapter of the American Concrete Institute. Today we're going to listen to Indiana's very own Christopher Toll talk about ACI 302 construction of slab on grade. Chris is a professional engineer and slab consultant. He runs CRT Consulting. He is the go-to man for slabs in the state of Indiana. It's an honor to have him here today. We're putting this on in conjunction with the Indiana chapter of Civil Engineers, the Indiana ICRI chapter, Indiana Ready Mix Association, and the American Concrete Pumping Association. I'm going to turn it over to Christopher Toll now. I will keep everybody muted. If you have questions, please send them in the chat, and we'll get to them. At the end, we'll have a Q&A session with Mr. Toll. So at this time, Chris, the floor is yours.
Well, I appreciate it. Thanks, guys. Everybody can hear me all right, I assume. So unfortunately, I've done quite a few of these on GoToMeeting, and I can't see you or myself. So if Larry, if I have some technical difficulties and nothing's showing up, jump in and let me know. So it certainly is a pleasure to be here today. And the Indiana chapter of ACI is certainly something close to my heart. Been very much involved in that since the early 90s. And Larry's done a good job of pushing things forward with the ICACI in terms of certification and other things. So it's great to talk to you a little bit about 302 and construction of slabs on ground and slabs on grade, and certainly a hot topic. These big boxes are booming all over the country. There's projects going on everywhere. Amazon, Walmart, everyone, e-commerce with COVID, e-commerce is just exploding. So there's quite a bit of work going on there. And so we'll spend a little time talking about 302 and construction of slabs on grade. So see how that goes here. All right, let's see if that's going to work. We're going to go here. So here's my background. I am the only engineer in the state of Indiana that didn't go to Purdue, is what I've been told. Went to Cornell, graduated in the late 80s, and my work experience is pretty varied. I went to work for a large concrete contractor right out of college, and did a lot of work and was kind of on their flat work circuit. And it took about 8 minutes for those guys to realize I was a young kid on salary. So I was the one who was setting up the slick line at 3 in the morning and the one sawing the floor at 9 at night. So got a lot of good experience there. I left that company, went to work for a construction manager doing some work down Eli Lilly, doing that kind of work. And then it was in the ready mix industry, first with the Ready Mix Association, then with the Ready Mix producer here in Indianapolis, where I was vice president of production and quality before I started my company, CRT Concrete Consulting, in 2007. And I focus on a relationship approach to some technical issues. So I'm very active in ACI. I'm a voting member on the committees that you can see there. Slab, certainly, decorative, roller compacted, parking lots. I'm the current chairman of the parking lot and site paving committee. I'm on the residential design of slabs and impervious concrete. So my background, I'm kind of a pavement slab material kind of guy. I could design a retaining wall for you, but it'd probably take me a long time to do it. So I'm more of a material and pavement type person. I do have my PE in a few states and lead AP, and we will talk about some green building as we kind of go through here. So that's my background, and I work in these areas, and certainly slabs are keeping me busy. I've got industrial distribution center slabs going from Miami to Seattle, California, New Jersey, all over the place in between. So I get to travel and see the country a little bit. I know about wearing a mask on an airplane as well as anybody. So I've got a lot of experience and got to work with a lot of great contractors. So we'll talk a little bit about that as we go too. So this is the document, the committee, ACI 302. It's a very good document. And if we talk a little bit about the demographics of the people on the committee, the reason this document is so good is that there are a lot of contractors involved in writing this document, the American Concrete Institute document. So I don't know if you're familiar with these consensus-based documents, but they take a long time to produce. everyone has a vote, and they end up being pretty good. And the worst thing I think we can do, guys, is to have a document about construction written by a bunch of engineers. That's not the best thing. So what we really need is to get a document written by contractors for contractors that help contractors be successful in what we do. And in my consulting business, yes, I am a consultant, but largely on these projects, I'm more a facilitator. And I would tell you, it is my job as a consultant to make sure that all parties involved are successful. That the concrete contractor is successful in putting in a quality slab, the ready mix producer is successful in delivering that slab, the developer is successful of building the building and leasing the building, testing firm does a good job, so we can all do this again, get paid, and do it on another site. So I try not to say my way is the highway. I try to be more inclusive and try to say that this is how we are going to do it and what is in our best interest, not in my best interest or your best interest, but in our best interest. So if we can have that good cross section of people and make sure that we have all parties represented, then we can have better documents and consequently better slabs on ground. Here's the table of contents for ACI 302. It's currently being rewritten. Kevin McDonald of Baton Industries, he is the current chair, and I'm a voting member on it. There's probably, I don't know, 35, 40 voting members on it. This is the current table of contents. As you can see, I'm not going to read all those to you. We're going to spend a little bit of time talking about some of these different chapters. I'm going to talk a little bit about the classes of floors and make sure that you're aware that there are different classes of floors. We'll spend just a little bit of time there. We're going to spend a little bit of time on site preparation and placing environment. Very, very important that we understand that. Then we're going to spend some time talking about concrete materials and mixture proportioning, something I'm pretty passionate about. I do have some pretty strong feelings on what a concrete mix should be and what it should look like and the workability of that mix. Spend some time there. Then we'll spend some time on placing, consolidating, and finishing. I am not a finisher. I tell my customers two things. One, if you see me with a trowel in my hand, we're all in a lot of trouble. And two, if you think I need to have a trowel in my hand, you haven't hired the right finishing contractor. So I'm not a finisher, don't claim to be one. I just try to make an environment where that placing and finishing subcontractor can be successful. And then finally, we're talking about curing and protection. And I'm not going to talk a little about joint filling, but curing, protection, densifying, those kind of things. There's some hot topics that goes on there. I've got a slide about what I think is coming to construction of slabs on ground, and then we'll wrap up with a kind of a little conversation about a pre-placement meeting if we have time. So with that, we'll jump right in. Here's the classes of the floors. That's right out of ACI 302. You can look through there, and a lot of the floors that we're looking at now are in industrial exposed surface, industrial vehicle traffic such as pneumatic wheels and moderately solid soft wheels, industrial floors, manufacturing, processing, uniform subgrade, rack layout, all these things. These are where a lot of our floors are happening. Heavy industrial are done too with some toppings. I don't see many topping slabs or shake slabs happening much anymore. We get such hard floors with some of this ride-on finishing equipment we'll talk about, that most of the floors that we see are very much just standard conventional concrete slabs on ground. Next week at this time, we'll talk about the ACI 360, the design manual, so I won't talk too much about some of the design stuff. We'll hit that next week. One thing I do want to talk about is the vapor retarder and what's going on with that. They have a flow chart in 302 that you should be aware of. This thing changed several years ago. And the bottom line is this: if you're going to have moisture sensitive flooring, or you're going to be storing product maybe in cardboard boxes on the floor, you need to have a positive vapor retardant. And that's very, very important. And there's a lot of misinformation out there about the impact of the vapor retarder. A lot of people think that vapor retarder increases curling. I'm not so sure about that. I think that the vapor retarder, lots of times we're building on some wetter sites, and this curling thing, we'll speak to that a little bit. The curling thing is a differential moisture condition where the top of the slab is drying out more than the bottom. So if the bottom of the slab is continually wet, it will take much longer for the bottom to dry out, and we could have more curling. So a lot of my customers now and a lot of these e-commerce people are requiring that their whole slabs, the whole slab be placed on a vapor retarder. Now, these aren't just 10 mil plastic you go to Lowe's and buy. These are more substantial products that will last longer. So I would be in the practice of understanding that more and more of these slabs are going to be put on plastic vapor retarders. Does anybody have any questions about the vapor retarders before we move on? Nope. Okay. We could have some dominant joints there where we have larger saw cuts opening up. We can talk about that if we have time, but note that if we do have a vapor retarder, we're putting the concrete right on the slab. So what we want to make sure that we do is that we have a very solid sub-base material without rutting. In preparation of this seminar, I tried to leave the state of Indiana, so when I show the trucks that I don't make anybody mad. So you can see that this is a very good sub-base material, and we're not getting a lot of rutting in this environment. So as far as the condition of the building, I'm a big fan of pouring inside and enclosed when you're dried in. This is a precast building. The roof and the membrane are up. So this is a rain or shine environment. If it's pouring down rain or if it's a nice day, we're pouring slabs. And I think that's the best way to get the best slab. There are a lot of markets that are tilt-up markets along the Gulf Coast, out in California, that do tilt-up work. They're a little more challenged because you're out in the open and you're placing the slabs before your building is up. And I would say certainly that the quality of the slabs are in the precast environment with the roof on is better than in the tilt-up market. So sub-base, I want to make sure that that's a good uniform sub-base. I'm a big fan of partnering with the geotechnical engineer to make sure that the sub-base has been tested and proof rolled to make sure that we don't have any problems. I'm also a supporter of having the finishing contractor have a roller and a skid steer available. So if we do have any minor rutting, we can backtrack that sub base and recompact it to make sure that we keep the slab uniformly supported. So I think we can all agree that the slab is only as good as what we put it on. If we put it on a bunch of mush, then the slab's not going to be very good. And so we need to take some care in concentrating on getting a good uniformly compacted subgrade that will be supportive of our slab. Any questions on sub-base? I do see lime stabilized, cement stabilized sub-bases in order to dry these buildings out. I'm seeing more and more cement stabilization these days, but still the most common is lime stabilization. So some of the issues with sub-bases that I do want to point out, there are parts of the country that have expansive soils that you got to deal with. That the soils, when they get wet, they swell. That is certainly an issue that you need to deal with, and there's ways to work around that and some local efforts to do that. Fortunately, here in Indiana, we don't have a lot of that condition. And there are parts of the country that you can have large fill sites and long-term consolidation. So You get down into northern Kentucky, you can have a site that has 30 feet of fill and 30 feet of cut in one site. So if you have lots and lots of fill in there, big quantities of fill, 10, 20, 30 feet, it's my opinion you need to monitor long-term consolidation of those fill materials, because they're going to settle over time, and you need to make sure you understand that settlement, and that settlement is done before you get into pouring your slabs. Furthermore, when you get into those large cut fill sites, a lot of times these slabs will be sloped 0.5%. 1 degree slope. Guys can set their laser up on a slope. The formwork is sloped. You can't see the slope in the building when you're there, but it might be 5 or 6 feet savings in fill from one side of the building to the other. So those are some things to pay attention to. And those are certainly some things that you want to, I've seen before when the slab is sloped, that, you know, you have a pre-placement meeting and you talk about all these things, and then the laser screed operator comes out and nobody tells him it's sloped, and then you can get into problems. So all these things need to be discussed and talked about up front. So that's the sub base. If we look at materials and mix proportioning, I want to talk a little bit about the mix. There's been a lot of work done on the mix these days for these slabs, and a lot of good work has been done. So what really the philosophy of these slab mixes is, if we can get a bigger aggregate, we can have less cement, which is less paste, which is less shrinkage, which is less curling. That's kind of where things are going in that, and it's been pretty successful around the country. Certainly successful here in Indiana, where we would blend some 8s and some 11s and some 4s or whatever to get a good slab mix. So if we look at that, and what we really want to do is we want to limit shrinkage. If we can limit shrinkage, we can limit curling, and we can have less rocking panels. I won't say no rocking panels, but less. So this is curling. I took this photograph a few years ago, and I was walking around on a job site and was running around in this mud, and I thought it was a perfect illustration of curling. In this situation, the top of the dirt dried quicker than the bottom of the dirt, and you can see how the corners had curled up. That's what our concrete slabs will do. And this old PCA picture shows that very well, that the slab lays flat. When it dries, it tends to move up. I would say that my picture of mud is a very geeky pencil pocket protector photograph, but my colleague Howard Kinnear took it further. He did some time-lapse photography on a couple of wet sponges to illustrate curling, and it is pretty remarkable. I'll see if it'll play for you. So as the top of the sponges dry, you see how they raise up, and there's a gap in between, and the center of the slab here is on the center of the sponge is laying flat on the countertop, but the edges are curled up. This is exactly what a slab does. Exactly what a slab does. So if you have a fork truck coming over here, you can break it, or you can have some damage to joints, as illustrated in this video here. You can see the movement there that we've lost aggregate interlock at that joint. We lost load transfer, and the joints start to get beat up, and then you start to see joint damage. When we have to repair this joint damage, this can get very, very expensive, $10 a lineal foot to repair, very costly, very intrusive to the operation of a distribution center. So we got to make sure that we have mixtures that are as low in shrinkage and low in curling as possible. So if we talk about what shrinks, does the rock shrink? Generally not. The sand doesn't shrink, it's the paste. So if we can minimize the paste, then we can minimize shrinkage. And minimize shrinkage, we can minimize curling. And a lot of us were moving to larger coarse aggregate. Number 4, some 1-inch retained on the 1-inch sieve material. So we've done a lot of that. And the strategy is that if you have one size big aggregate, it takes so much water here. If you have one size small aggregate, it takes the same amount of water. But if we blend these aggregates, it might take lesser amount of water to create a given workability. If we can have less amount of water, then we have more strength, or we can reduce cement, further reduce paste, reduce shrinkage, reduce curling. That's our strategy here by reducing, largely about reducing surface area. So if we have small particles, if this is a one foot cube, and we take 27 of these to make a cubic yard, if they're 1 by 1 by 1 by 1, you'll see here that the surface area of all these particles, when they come apart and you put them into a concrete mix, when they all come apart, they are 27 cubic feet or 162 square feet of surface area. If we had the same volume with a larger particle, we would have only 27 cubic feet of surface area. So if we have a larger rock, larger particles, it takes less cement to coat the particle per given volume, and we have less paste, less volume, less shrinkage. So it doesn't take a brain surgery to look at these two different concretes to understand what is a better concrete. You can see here very high mortar fractions, still has some coarse aggregate, but this is a much better looking concrete. So we call it, these old concretes, we have them quite a bit. I think when the industry is generally doing a good job about doing aggregate gradation and understanding what needs to happen on these concrete mixtures to make sure that they are well graded. There are several tools to do that. I've made my own. This is an example. Actually, I just changed this slide this morning. This is a mixture I had down in Florida. That down in Florida, they have some very, very fine sands. So they had 8.64 cubic foot of this sand. If you look at the sand, 33% passing the number 57, FM of 1.9, very, very fine sand. So when you look at the coarseness factor chart, I think you guys are familiar with that. It's up here in zone 4, commonly called the courthouse zone. If you look at the tarantula curve, which is becoming more and more popular, the blue curve, it's way outside of the tarantula curve here down at the bottom. You look at the mortar fraction, I've never seen a mortar fraction like this, 60-something%. We blend in some different aggregates, we change some proportions of the different constituents. We bring the coarseness factor chart out into zone 2. We bring everything pretty close to the tarantula curve, and the mortar fraction has dropped from 63 down to 55%. So by doing these tools, now I'm not suggesting that these mixes should only be done on paper. And I don't go into a market and tell a guy how to make a mix. They're your materials. You understand them better than I do. So I'm not about to do that. But we do have some tools to get an idea of what these mixes look like every day before we send them out on the project. So by the way, all these things are done by volume. These are 2 different mixes here with the exact same weights from different sources, and they're way different looking mixes. So all that stuff is very, very important to make sure that we have a good concrete mixture. I know here and around the state of Indiana that all the ready mix producers are very familiar with the well graded mixtures, lowering cement factors in order to get a workable mix that can be done, can be used very well on the job site. Are there any questions about the concrete mixtures? All right.
I've got none in the chat right now, Chris.
All right, Larry. We'll press on. We might get done early. Okay, great. Talk a little bit about placing and finishing, consolidating, those kind of things. So again, I am not a finisher. but I've been on hundreds and hundreds of these placements. I probably am on 50, 60 of them a year. And I can tell you that successful placements are very organized and struggling placements are kind of unorganized. Seems to be, and it just like my life, it seems like if I get out of bed and stub my toe on the dresser and my day doesn't start too good, then it just seems like the whole day just kind of snowballs. And I think these slab placements are kind of the same way. It's important to get off to a good start and get off on the right foot and get going well. And I think I think if you can do that, you can be successful. If guys are looking for their tools and doing that kind of stuff, then it can be a struggle. Certainly, the ready mix producer has a significant influence on the productivity of a placement. I've had a lot of people ask me, why, how do people determine the width of these placements? We'll talk about that a little bit. But the ready mix producer is a partner in these slabs, and certainly the labor costs to the contractor, and frankly the labor costs to the ready mix producer go hand in hand. If the ready mix producer and the placing finishing contractor are on the same page and have some synergy, then the placement will be very efficient and they'll get down quickly, and both parties will be productive in doing that. If one party is not on the same page, if the concrete's not being placed as quickly as the ready mix producer is delivering it, and trucks back up, we start to lose slump. We have some quality issues. That's not a good thing. Furthermore, if the ready mix producer is not placing concrete quickly enough, then we can have some cold joints and other issues that the concrete contractor's got to deal with. So it really is symbiotic relationship, and it needs to be a win-win. So here's what's happening in these days on these pours. This is a pour layout on a project that I was working on. Each different box is a color. These are 50-foot bays, so we're going. This is 100 by 50, 100, 150, 200, 250, 200. So these are 125 feet wide, 150 feet wide, very wide pours, very long pours. And if you look at the quantities that are being placed today, don't count the pour back strip. 40, 50,000, 53,000, 57,000 square feet a day. Guys, these contractors are getting it, and they are getting it in big quantities. They're getting it flat and level, and they're getting some good looking slabs. So my job as a consultant is to facilitate this, because who wants this? This is what all of our customers want. If XYZ distribution wants their building, man, they want it quickly. So we're pouring big quantities of concrete, and we're pouring a lot every day, a lot of square foot, a lot of cubic yards, a lot of truckloads. So if you just think about the effort in doing these things, if you think about the manpower required to do one of these placements, it's really something else. If you think about how many tankerfuls of cement has to be delivered, how many triaxle loads of sand and coarse aggregate have to be delivered to make one of these placements, it is a tremendous coordination effort. And everyone needs to have respect for the other entity to make sure that we respect their part of the project and understand what's involved. These cement plants, they're not 10 minutes away. They might be 2-3 hours away. So if we're going to pour at 3 a.m. and someone cancels that at 1, there might be 6-7 loads of cement on the road for that job, and then the producer scrambling to get there. Furthermore, if the ready mix producer can't commit to his quantities, then the labor involved, these guys travel all over the place, there's costs associated there. So I think just like anything else in life, it's communication. And we'll talk about that towards the end of the talk. Communication is important to make sure everybody gets what they need as far as these large slab placements. So if you look at these things, some things that can be a bit of a challenge. So here's a door down here. So we have, say, this is the first placement. That laser screed works left to right. So here's a challenge right off the bat. So we're coming right in here. And Larry, is my mouse showing up okay?
Yes, it is. And we've got a couple questions when you've got a minute.
Okay. So let's have the questions. Go ahead.
Okay, the first one is from Dan McCoy. He wanted to know if you could share with the gradation requirements for NDOT that will be implemented in September.
Yeah, I can. So hello, Dan. So what NDOT is doing, NDOT is implementing the tarantula curve requirement. They're requiring the aggregate producers to produce a coarse aggregate that, when mixed with some theoretical sands, coarse sand and a fine sand, conform to the tarantula curve. So NDOT is requiring this well-graded mixture starting in the September letting. What's the other question, Larry?
And the next question is, what are the most recent changes and improvements to 302, which I'm sharing that one with you so that you, as you go through your presentation, you can kind of touch on those.
Yep. Okay. I will try to hit that at the end because it's currently under revision now, and I could probably answer that.
Okay.
But I will tell you the tarantula curves going into the 302 document too. That's one change that's coming in 302. All right. Okay. Catch up here. So if we come in here for a placement and we come down here, this is going, which way are they going to place this? Is he going to place it this way, or is he going to place it this way? If we're starting here at the wall, he's coming in, he can bring his trucks in here, laser screed moves left to right, then you know that he has to store his equipment over here when the placement started over here, and that's over 100 feet away. So that can be a challenge because this concrete's going to set before that concrete. So he's going to try to hurry over and place this concrete as quick as possible. So when this needs to be finished, then this is not too hard over here to be finished. So we have those conversations. We want to talk about those things. Or maybe the form work stays out here and then we come in this way and we go left to right. So then we have room to stage the finishing equipment. Not typically done that way, but we at least have that conversation. So all these pours are done in a big building like this. It's very important and very helpful to have coordination. I like, if we can, to have a one-way in and a one-way out if we can. We want to talk about washout on these placements. It doesn't do any good to get 180 yards an hour delivered when we have just place for 2 trucks to wash out and everything backs up at the washout areas. So all these things need to be discussed and coordinated. The form work that's being done these days, and this is one change that'll be coming to ACI 302, is this modified construction joint that we're doing here. But what we're doing on the form work is typically the form work has a beveled edge on top, a smooth edge, so we can finish right over the top of the concrete. So the form work needs to be straight. It needs to be shot in with a laser or a level. The formwork has a huge impact on your FL numbers. So we need to pay attention to the formwork. And certainly if you have one of these 0.5% slope form jobs, you need to make sure that your formwork guys know that that thing is sloped. Formwork's important. The other thing that is important is the coordination. So I mentioned to you that vapor retarder is being used more and more, plastic. We have dowel baskets, we have reinforcement, we have concrete placement, we have a laser screed. So there's a lot going on there. And there's guys like me want to make sure that we can maintain the quality of the sub-base material. Because I can tell you, if you're doing 1,000 yards a day, you're bringing in 100 ready mix trucks, if they're all coming in the same part of the slab, there's going to be some minor rutting that you're going to need to roll and correct throughout the placement. So I want to make sure we keep our eye on this. I love this photograph. This is a great coordination photograph. So what they have done is we've got some. The whole job's got vapor retarder. This is going to be 50,000 square feet. The whole job's got vapor retarder. This job has got reinforcing steel. So the contractor has placed the vapor retarder where they're not going to be driving. On the left and the right sides, and then we'll put the vapor retarder down on the fly. So here's the steel that's down. We drive over this Bigfoot mesh. It's chaired up a little bit. We don't drive on where it's already chaired. So everything's good. Places the concrete. We'll put down additional vapor retarder. You can see that's the strip on the side. They're filling in the vapor retarder. And they're far enough ahead to where we're not trying to tape the vapor retarder where there's concrete on it, because the tape won't work, and we're far enough ahead that we're not inhibiting the progress of the laser screed. So that goes down. Then after the vapor retarder comes in, you can see it's being taped on the fly. Then we come in and we are installing, I shouldn't say we, I stood there and took the picture. They are installing the Bigfoot mesh, making sure that the lap is correct, tying as we go, and chairing it up. So as far as placement, sorry, Dan, I prefer to place out of a ready mix truck, but there's some things that can inhibit that. Vapor retarder, reinforcing steel, underground vapor mitigation systems can be deterrent on that. I like to get involved in these projects sooner rather than later. If you go into some industrial settings like Pittsburgh or New Jersey, where they're tearing down buildings and building new buildings, there might be some nasty stuff in the soil that they're trying to keep from coming up into the slab. And there might be a vapor mitigation system where they have little fans and tubing under the slab. And that system needs to be coordinated with the laser screed, with the concrete trucks, to make sure we don't collapse that system during placement. So all that stuff needs to happen. So here's a placement out of a ready mix truck. That's that same job. By the way, here's a life lesson. Don't order 4-foot bolsters. Cut them up and get these little bitty bolster pieces that can be easily put down in. You're not trying to lift up a whole sheet and shove a bolster in there. That's a good lesson I learned from this contractor. So here's the placement going on. He's trucks dumping the concrete. We're vibrating around the dowels and stuff. So looks good. We do place by pump at times. This is a job I worked on down in Florida. A lot of sandy soils down there. A lot of pumping that happens down there. That they pump. They pump the concrete, still a well-graded mix. We still are able to use a bigger aggregate. If it's well-graded, we don't have a lot of problem pumping it. Now, we're not laying 500 feet of line, not saying that, it's a boom pump. We can convey these placements. This is a project where that vapor mitigation system was in place and we couldn't drive concrete trucks on it. So we had to convey it. And the conveyor would only reach so far on this project, so we actually had some large buggies to place the parts that the conveyor could not reach. So lots of ways to place the concrete, and you can see that all these mixes, they've got pretty good coarse aggregate sizes. We've got these good looking mixes going down. As far as the slump of the concrete, I really don't have a large opinion on the slump of the concrete within reason. If the contractor wants to place 4 plus or minus an inch of concrete, I'm fine. If he wants to place 5 plus or minus an inch of concrete, I'm fine. If he wants to place 6 plus or minus an inch of concrete, I'm fine with that too. I haven't had anybody want to go more than a 6. So it's either, most guys are 5 plus or minus an inch, and some are 6 plus or minus an inch. all my 4 plus or minus an inch jobs that, yeah, they say 4 plus or minus, but they don't have any interest in the minus section. I think I saw a question pop up, Larry.
Yes. There's a couple. Ryan Decker, he asked, first one is, what are the top 3 things contractors do that cause defects or subpar products being used?
Placement problem. One of my pet peeves is leaving the finishing equipment on the slab and leaving the fan on. It's a no-brainer. Take the equipment off the slab at the end of the day. That's my biggest thing. I don't know if I have a top 3. Oh, I'll show one here later. There's one that I have another pet peeve I'll show later.
Okay, another one is from Ryan Decker is ACI 302 isn't just for super flat floors. How does it apply elsewhere? And does 302 cover exterior parking lots?
Second first, no. ACI 330 covers concrete parking lots and site paving. You should take a look at that. The site paving portion is a good document, kind of focused on the laser screed. So that, and as far as super flats and F-min, I wasn't going to speak to that, but I can. What I'm seeing now largely is that, well, I'll tell you what, why don't we save that for the end? Because that might be something we could talk about a little bit. Because that's something that's, make sure you remind me of that, Larry.
Okay. And then from Noah, we have, when placing concrete using trucks, do you have issues with damaging the vapor retarder or not getting the steel placed correctly?
No, not if you pay attention, and not if you use a proper vapor retarder. 10 mil minimum, 15 mil would be better. And 10 mil is what you're going to need for a proper vapor retarder anyway. And this is a Stego product that's on the screen now. It's very tough, and no, we don't have a problem. And if we have that coordination done correctly, then it can be done. Now, interesting that you bring that up. We'll go back here real quick. You know, I was on a job, and I said, hey, I want to talk about putting the vapor retarder and the steel down on the fly. And the contractor said, oh, no, we can't do that. And I said, well, we kind of did. And what was funny is this picture was from the same company, a different division of the same company. So it can be done. Now, look, I'm not saying it's convenient. I'm not saying it is. If you have vapor retarder and you have maybe dowel baskets and all that stuff going on, it's a pain in the ass. And it is a huge coordination issue. It can be a safety issue if you're not questioned. There's a lot of people out there and a lot of trucks. So I'm not saying it's not inconvenient. I'm not saying that at all. I'm not saying it's not difficult. It is difficult, but I like to keep my eyes on that sub base to make sure we can keep that thing in good shape as we go along. All right, talked about that. Next thing is consolidation. The laser screed does a good job of consolidating the concrete. As we move forward, you'll see the laser screed doesn't get around the edges. So we asked the contractor to vibrate the concrete around the edges, and I asked them to vibrate even if it is an edge without any steel, no dowels or no hairpins or anything, even if it's just up against the expansion joint on a wall, to vibrate the concrete. So to have a handheld vibrator. So that's generally it. I would say generally that contractors, if there's dowels or reinforcing steel, they do vibrate the perimeter. If there's not any, then I gotta ask them to vibrate. Some people bull float after the laser screed. Some people don't. I'm not really sure why. I don't know why I didn't put a laser screed photo in there. It must not have popped up. Then you know, almost all of these jobs are being done with laser screeds. So they're done all the time with laser screeds, and there's different models of laser screeds. So it's important for these projects to be put down flat and level. So I'm stammering to show you a laser screed photo. I don't know why I didn't have one in here. I'm going to slide one over. So these machines are fantastic. Somero has the lion's share of the market. Lingshan is creeping into the market. There's a laser set up on the project, and these two receivers receive the laser signal, and they strike off the concrete to grade. There's some science involved here. There's an art involved here. Guys got to know what they've been doing. We must have laser calibration. That is what I want to do is if I want to go down at the end of the pour, I want to put the laser on the formwork and make sure it reads correctly. Then if I rotate that laser 180 degrees and go back to that same spot, I want to make sure it's accurate. So I don't think in general that these lasers are calibrated as much as they should be. And what I kind of see is that each of these placements are kind of a unique placement in and around a building, and sometimes they don't get tied together very well. So that's the laser screed. And then some people do bull float after the laser screed. Some people do not. Some folks think, and I would agree, that when that laser screed drops down to the surface, it makes a little dip. So there's some people that like to come across perpendicular with a channel float and to take care of that little dip, and then it helps with their flatness numbers. If you want to wait for the bleed water, this is you can see there's a load here that was a hot load down here. This is down in Florida. So you got to wait for the bleed water to come off of the surface. Sometimes there's a lot of bleed water, and you got to squeegee it off. Actually, I'm kidding. This is a job I was on in Savannah, that a tilt-up job, and it started raining like crazy. Pop-up shower we weren't expecting, and this is what the crew had to do. Is they got on there and they squeegeed the water off the slab. It's what you got to do. I have seen slabs that bleed so much that the guys have got up and squeegeed them off. And in Indiana, I would say if you have a bunch of bleed water where you're removing bleed water from the slab like this, then you got a mix issue. You got something going on with the water. Now you go down in Florida where it's crazy humid and nothing vibrates, or this is in Savannah or stuff like that, there could be some bleed water, particularly with these vapor retarders where you could have some bleed water situations. But you got to wait for the bleed water to come off the slab before you start your finishing process. Then the finisher will go into a panning process, and he'll pan perpendicular to the direction of perpendicular to the direction of placement. He'll pan right over the edge, and that's why we taper that edge to give a crisp edge. And we want all this stuff to happen and make that easy for him to do. So all this activity coming over the edge is a good thing. As much machine finishing as possible. Guys will go one direction, the other direction, diagonals. They'll pan as long as they can pan. And again, I am not a finisher. They'll pan as long as they can pan, and then they'll go to combination blades. Oh, excuse me. Now, some guys like to bump cut to get a flatter floor. So during the panning, after the panning process, they'll come out on the floor and scrape the floor. They call it bump cut. And these will get your FFs up high. This is very rarely done. The reason that it's done is for much higher FFs, but you got to be careful with aggregate shadowing. We are packing the aggregate into the mix, and then if you bump cut some of the paste off the top, you can have coarse aggregate particles at the surface and have some aggregate shadowing. So again, this isn't done very often. There's a guy out in California that's developed this box that he drags behind his 10-foot machine and bump cuts as he goes. And this guy gets tremendous FF numbers. Quite a good piece of equipment. So you pan as long as you can pan, then you go to some combination blades. You can see this job. This is out in California, and sun's coming up. He's got his combination blades going, And then we go into steel finishing blades and finishing process. And we try to get these floors as tight and as finished as tight as we can get without burning the dickens out of them. And they tend to look pretty good. Any questions on the placing and finishing?
We don't have any new questions in the chat.
All right, good. So someone asked about what's new is that we talk about curing. We talk about curing, and few slabs are cured. There are some guys that water cure these days. Most slabs are not cured per se. There is an early application intensifier. Okay, it seems to work. We seem to get the abrasion resistance from these heavy machines with these steel blades. Pressure dewatering the surface and getting some density into the surface. So most of these slabs have an early application of densifier. And that's one item that'll be added to ACI 302 is acknowledging the application of the densifier immediately after finishing. So this is a job that got finished. You can see a guy's got a Chapin sprayer, and he's spraying on the densifier early application, and with some microfiber mops, he's wiping it out. So that's and this seems to work pretty good. What I would recommend is the early application densifier, and then when the whole project is done, if you've got the money, then you go ahead and fully densify the project after the slabs are cleaned. So there's the densifier. Then we go into the saw cutting, and the technology these days. I'll just say that there's a few things that have made these slabs in my career since I came in the late 80s. There's maybe 3 or 4 things that have really benefited slabs on ground. The first thing you would say is the laser screed. The laser screed is fantastic. We're putting down these floors flat and level like they were never done before. It has allowed us to put in 40, 50, 60,000 square feet a day. When I worked for a big contractor right out of school, we were doing 20,000 a day with a truss screed. We were getting it. So huge quantities, flat and level. Laser screed certainly a big developer. Second thing is the pans. The pans that we do the floating with on the bottom of the machines. These pans, you see the pan here. These pans kind of chop the floor down and get them flat. The double rider, when I came out, there was triple trowels, but now we got these doubles are better, and we have these pans and these things. Some of those pans, they're 5 feet, 6 feet, 12-foot machines, 6-foot pans have certainly helped the flatness of a floor. And thirdly is the soft cut saw, the early entry saw, the early entry sawing technology. We would have to cut the next day, and sometimes you come back and the slab would be cracked. So with the early sawing technology, we've been able to saw these slabs in a timely manner to damn near eliminate out of joint cracking. So I'm a big fan of the early entry sawing. We kind of saw a T/5, a fifth of the thickness. Some markets pinwheel off of these HSS columns. I don't like the pinwheel. I think we can wrap them with foam and pull right to the middle of them. I think that's fine. And then we need to chase the end of the cuts. So here's the system. A soft cut saw with a vacuum. Because of the silica laws, we got to be vacuuming up all this dust. It's probably a good thing. So we're able to do that. We use joint protectors. Here's one saw cut. You can see the line for the next saw cut. So we put this joint protector in here so we don't spall the edge when we come and do the cross cut. We want to make sure that we have the proper thickness, the proper depth of cut, so we can get that construction joint to activate. Ryan, you asked, one of my things is in every meeting we talk about finishing off the saw cuts, and I see this on almost all the jobs. So we're going to ask you to take an angle grinder and finish those cuts off so we don't have these random cracks here at the end. They just don't look as good as they need to look. So any questions on saw cutting or densifying? All right. Well, I'm going to finish up here with a few minutes. I want to talk about a pre-placement meeting. Drag this over here. So we try to have, I work and I try to have pre-placement meetings where I'll have the engineer, the building owner, the concrete consultant, that was me, the joint filling guy, the concrete contractor. Uh-oh, got an error. All right, there we go. Concrete suppliers there, the testing firms there. We have all those guys there. And we talk about expectations, owner expectations. We talk about quality control reviews, submittals. We talk about a readiness check set. We have site access. Are we dried in before placement? We talk about schedule. We talk about environment, hot weather, cold weather. We talk about air quality. We talk about the subgrade system. We talk about, is there a vapor retarder? Where is the vapor retarder? What's getting it? Has the exterior been stabilized? We talk in detail about the ready mix. We talk about the slumps down here. What slump are we going to place? We talk about all these things. I see these mixes submitted 4 plus or minus an inch all the time. You ask the contractor, I'm placing a 5 plus or minus an inch. We got to work through those details. We want to make sure the aggregates are non-reactive. They want to make sure the decants are under control. We want to make sure the mixes are well graded. What admixtures are being used? What accelerators are going to be used? The non-chloride is better for color. Calcium chloride is cheaper, but it can discolor the floor. I want to talk about the air content. I don't want the finisher to get into a blistering situation. So I like to set a maximum air content of 3%. Exterior, sometimes we talk about that. We talk about the gorilla in the room, you know, the added water. Are we going to add water? How are we going to add water? Who's going to add water? Who's going to reject trucks? Well, how's that going to be? How's the concrete coming? Is it coming from 1 plant, 2 plants? Are they the same materials? What about the washout? Do we have room for all these trucks? How many washout areas? Who's in charge of the washout areas? Will there be a light at the washout area because we're pouring at 3 in the morning? Testing firm, we want to talk about that. Do we want to bring the first load in a little early so the guy can test it without everybody screaming at him wanting to have a concrete? Will the testing technicians be ACI certified? Where are we doing the sampling? ACI sampling requires 2 portions of a middle load. I talk about, hey, we're going to get it from 1 portion of the middle load. We'll talk about that. What tests are we going to do? What's the frequency of the cylinders or the beams? How are we going to protect these? How are we going to protect these? Keep these samples 60 to 80 degrees on job. How are we going to do that? What are the FFL requirements? Where are we going to test? Who's going to get the results? Are we going to do any construction joint testing? All these things are here. Are we doing gloss testing, coefficient of friction testing, roughness testing, all that? Is that going to happen? And then we talk about the pre-placement activities, the formwork, the reinforcing steel, the load transfer, the dock levelers, what's going to happen to dock levelers, how we're going to saw the dock levelers, how we're going to do the interior column isolations, how we're going to do the wind breaching, how we're going to do the perimeter, how we're going to do the future mezzanine columns. There's a scrubber dump in here. How are we going to handle that? All these things. How are we going to do? Are we going to do sweeps on drains, sweeps on cleanouts? No expansion joint around the cleanouts. All those things are talked about. And then we talk about the placing and the finishing and the curing. We talk about the saw cutting, and we talk about the joint sealing. So we talk about all that stuff, and we get a good communication going on there. And I simply say, hey, all we ask is that you do what's in your contract and what we agree today in the pre-placement meeting, and you know, we'll have a coordinated effort. We'll all make a little money, and the guys will bring us back to do it again. So as I wrap up here, things that I believe that the concrete contractor should get ready for is a couple of things. First is sustainability. couple of us were on a virtual fly-in where we were meeting with the Indiana legislatures, the Cement and Aggregate Group, about a month ago. And, you know, we hear about this sustainability stuff and green building, and we all kind of roll our eyes and like, yeah, well, you know, there's a Democrat in office. We'll wait for a Republican to get back, and then it'll all go away. So our first meeting on that initiative was co-chaired by Republican Senator Braun. And man, it kind of floored me that we've got Republicans talking about sustainability now. Guys, I got to tell you, it's coming. And it's coming at us like a freight train. So on these slabs, God dang, guys, I know they got to set right. I know they have to. But you know, we've got some cement producers that have got 1L cement coming out. It's out there now. We need to figure out how to use that. We need to figure out how to make that successful. Not just figure it out. We need, as a concrete industry, we need to embrace sustainability. We need to understand how we can remove our carbon footprint, how we can lower our carbon footprint on concrete construction. We need to do that. We need to embrace it, and we need to move forward with that. So that's one thing that I would encourage all of you out there, is to have your eyes and ears open on the sustainability front. Second thing, on the flatness and levelness, this 2 foot boundary, where they say stay 2 feet away from construction joints and columns and all that, that's going to go away. A lot of these slabs have got robots on them. They go over construction joints. They go near columns. So a lot of that boundary stuff is going to go away. And the overall FFFL versus to the local minimum, that's changing as well. On past pours, we would say the overall FFFL applies to the whole job, all 10 pours, and the local minimum applies to 1 pour. That's not working anymore. That when that was initially put into place, we're pouring 20,000 square feet a day. What we're pouring now is 60,000 square feet a day, 50,000 square feet a day. So the local minimum is going to apply to each, the overall rather is going to apply to each placement. And then the local minimum will apply to like a bay area. So the testing firm would go out and measure a pour. If it didn't meet the local minimum, then we would start looking at bays and what bays did not meet the local minimum and what corrective action would be needed. So that's the third thing. The fourth thing is the vapor retarder is going to be everywhere. I've got one customer that's already pulled the plug. Every one of their slabs has got vapor retarder everywhere, and others will be following. So those are what I see coming. As far as revisions to 302, I think the early application of the densifier will be addressed. I think the modified construction joint detail will be addressed. I'll drag that over here for you here, where we're since we're doing more and more of these projects on vapor retarder, we're finding that some of the construction joints are opening up a little bit. So what we're doing is this detail here is that keeping the diamond dowel spacing at 18 and then putting a number 3 bar 36-inch long in between to give that, hold that joint together just a little bit so it doesn't open up so much, because we don't want to have a dominant joint. So I think 302 will recognize this detail coming up. I think you'll see that come into the document as well. So that is all I have to present, and I'm happy to answer any questions that anybody has.
Chris, thank you. And if anyone's got any questions, just take yourself off mute and ask. We do have one in chat. So the question was, what is the difference between vapor retarder and densifier, or basically curing compounds instead of a vapor retarder? And can they both be used to reduce moisture loss and improve curing?
Okay, vapor retarder is a plastic that goes underneath the slab, and its intent is to choke off any moisture migration from the subbase through the slab up into the space. That's a vapor retardant. And the densifier goes on the slab, and it is a chemical reaction between the calcium hydroxide and the densifier to form some crystals in the concrete. A curing compound is a membrane forming substance that limits moisture from the surface. So what has happened is that the old 309 curing standard that measures moisture loss, and it's really not a good test because it measures moisture loss on a broom finish, a wood bull float finish, so it's not really applicable. But we're finding that these slab on grade, these hard trout slab on grades, are being finished so tightly that they damn near meet the 309 without any curing compound at all. So frankly, most of these slabs aren't cured. Now there is an internal curing product out there that's being used and had some success being used, and more of these interval products are coming out there. So what I'm seeing mostly now is a vapor retarder, an early application of densifier, and then a complete densification maybe 30 days before the building's turned over.
Any other questions? Chris, I think they must be overwhelmed. No one's asking any questions.
Go an hour and a half, right? All right. Well, thanks for being with us, guys. Next week, right, Larry?
Next Thursday, we'll be covering ACI 360.
Great.
Same time, same place. I want to thank everyone. Again, Chris, it's a pleasure to always hear you speak. Anyone wants to get a hold of Chris Toll, I have his information. I can send it out if people want it. Chris, if you don't mind, I'll probably just send it out in an email so everyone's got it. Let him ask questions. He's always a great resource, so feel free.
Yards an hour delivered. So all this. All right. Have a good day, guys.
Thank you.
Hey, thanks, Chris.
See you guys.